The growing global crisis e-waste refers to discarded electronic devices such as phones, computers, TVs that contains hazardous material. E-waste, also known as WEEE, is growing rapidly due to our reliance on electronics. It poses serious environmental risks. Valuable materials like copper and precious metals can be recovered. Effective management guided by the principles of reduce, reuse, and recycle can turn pollution into potential, supporting a circular economy. E-waste management process. It starts with collection and sorting, followed by material pre-recovery and recovery, then comes hazardous waste disposal, dismantling, and testing. Each step plays a role in safely handling e-waste and recovering useful materials. E-waste work process. First, collection, gathering discarded electronics from homes and businesses. Next, sorting, separating hazardous components from recyclable materials. Finally, pre-treatment, manually dismantling batteries and toxic parts to prepare for safe processing. E-waste processing step. Step 1 is mechanical processing, where devices are shredded and crushed to separate materials. Step 2 is material recovery, extracting valuable metals like copper and coal. Step 3 is hazardous waste disposal, ensuring toxic residues are safely handled to prevent pollution.
Toxic heavy metals are metals that can cause serious health problems even at low levels of exposure. First one, we go through to the lead. Lead is the toxic heavy metal that can enter the human body through contaminated drinking water, oil paint, and industrial pollution. The next one is mercury. Mercury is another highly toxic metal that is commonly found in contaminated fish, industrial waste, and medical equipment. Arsenic is a toxic heavy metal often found in contaminated groundwater, pesticide, and industrial waste. Aluminium. Aluminium is widely used in daily life, such as in cookware, food packaging, and medicines like antacids. Although aluminium is generally safe in small amounts, excessive exposure can be harmful. Last but not least, nickel is a heavy metal commonly found in jewelry, coins, stainless steel, and industrial emission.
On the epidemiological data and global trends related to the heavy metal exposure among workers in the e-waste recycling sector. The data presented are derived from the peer-reviewed article and official WHO statistic, ensuring the reliability and relevance to occupational health. Global distributions of high-risk e-waste recycling by country, 2019 to 2024. This pie chart illustrates the global distributions of high-risk e-waste recycling activities between 2019 and 2024. China and India account for the largest proportions, followed by Indonesia, Thailand, and several African countries. These regions are dominated by informal recycling sector, where workers often lack adequate personal protective equipment. From an epidemiological perspective, this represents the place factor, showing where occupational exposure to heavy metal is most likely to occur. The high level of heavy metal exposure in China and India are driven by global e-waste trade, high domestic demand, and unsafe recycling practices. A large proportion of e-waste originates from developed countries and interest to illegal trafficking or mislabeling as second-hand goods. In both countries, informal recycling methods such as open burning and acid leaching are widely used without proper protection. This has resulted in extreme toxic exposure, such as in Indonesia, China, where inhalation levels were reported to be up to 56 times higher than WHO safety limits. China and India represent major high-risk region for occupational heavy metal exposure, as shown in pie chart. Global trend of unintentional poisoning mortality SDG indicator 3.9.3. This bar chart presents the global trend of unintentional poisoning mortality reported by the World Health Organization under SDG indicator 3.9.3. Although the mortality rate decreased from 1.4 per 100,000 populations in 2060 to 0.7 per 100,000 in 2021, this trend should be interpreted cautiously. The WHO attributes higher mortality particularly among men to occupational exposure in chemical-intensive industry, which includes informal e-waste recycling. Therefore, while the trend shows improvement at the global level, it does not fully reflect the continued occupational risk faced by the specific worker groups.
Small and unregulated e-waste recycling facilities are at high risk of heavy metal exposure. Long and repeated exposure can result in serious health effects, including neurological disorders, respiratory illness, kidney damage, and other long-term health problems. Children involved in or living near e-waste recycling activities are highly vulnerable to heavy metal exposure. Prolonged exposure can cause serious health effects such as impaired brain development, learning difficulties, behavioral problems, weakened immunity, and long-term growth and developmental disorders. Women of reproductive age and pregnant women who are involved in or live near e-waste recycling activities are at high risk of exposure to heavy metals. These heavy metals can disrupt reproductive health, increase the risk of miscarriage and pregnancy complications, and adversely affect fetal development. Residents living near e-waste recycling or dumping sites are at risk of heavy metal exposure due to the release of toxic substances such as lead, mercury, cadmium, and arsenic into the surrounding environment. Waste collectors and scavengers who handle e-waste are highly exposed to heavy metals during activities like collection, sorting, and dismantling of electronic waste. Migrant and low-income workers involved in e-waste recycling. They often work in informal and regulated settings with minimal safety measures, handling electronic waste through dismantling, open burning, and chemical extraction process, while limited access to healthcare exacerbates their risk.
Moving on to the risk factors. For the first one is the informal e-waste recyclers. Manual dismantling of e-waste, handbraking of circuit boards, cables, batteries, and cathode ray tubes, open burning of e-waste. Burning wires and components to recover copper releases toxic metal fumes and ash that can be inhaled or absorbed through the skin. And the lack of personal protective equipment. Most informal recyclers do not use gloves, masks, or protective clothing. Next is for the workers. Improper handling and storage of hazardous materials, such as batteries, CRTS, and printed circuit boards are stored without containment, leading to environmental contamination and high dust levels in the workplace. Metal-laden dust settles on surfaces and hands, causing chronic exposure through hand-to-mouth contact and long working hours and repetitive exposure. Contaminated environment at home and workplace. Metal dust settling on surfaces, clothing, and food increases chronic exposure through ingestion, and limited awareness and training. Lack of knowledge about hazards prevents safe practices and increases risk of adverse reproductive health outcomes. The risk factors for residents living near e-waste recycling or dumping sites. First is airborne dust fumes. The second one is contaminated soil. Leaching of heavy metals from e-waste contaminates the soil. Third one is contaminated water sources. Runoff from e-waste sites can pollute groundwater, rivers, or wells, causing residents to ingest metals through drinking water. One of the risk factors for the children is the smaller body size and developing organs. Children absorb and retain heavy metals more easily, making them more vulnerable to toxicity. And the poor hygiene practices, such as eating, drinking, or playing in contaminated areas, leads to ingestion of metal-laden dust and the contaminated living and play environment. Residual heavy metals in soil and dust at home or work sites increase chronic exposure. Risk factors for the waste collectors and scavengers. The first one is limited knowledge of hazards. Scavengers often lack awareness of heavy metals, toxicity, and self-handling practices. Next is contaminated equipment and tools. Use of old or shared tools increases the risk of cross-contamination and direct contact with heavy metals, and the working in informal or unregulated sites. Scavengers often operate in areas without safety regulations, leading to high-risk environmental exposure. Risk factors for the last one is for the migrant or low-income workers. The first one is the poor ventilation and overcrowded workplaces. Enclosed or semi-enclosed spaces allow accumulation of metal-laden dust and fumes. Poor access to healthcare, delayed diagnosis and treatment of heavy metal exposure exhibit long-term health effects, and the contaminated living conditions. Many live near recycling sites or in shared accommodations, leading to chronic exposure through dust, soil, and water.
Prevention and control. Systematic prevention and control measures must be implemented to reduce both short-term and long-term health effects. Based on the picture provided in this slide, we can see there are 5 steps in hierarchy of controls. Elimination. Elimination involves completely removing the source of hazard by discontinuing unsafe practices such as open burning of electronic components, crude dismantling of devices, and uncontrolled manual processing which release heavy metal, contaminated dust, fumes, and particulate matter into the environment. Substitution focuses on replacing hazardous materials, components, or processes with safer alternatives such as open burning or acid leaching can be replaced with cleaner, more controlled technologies like mechanical shredding, automated separation, or closed-loop chemical recovery. Engineering controls aims to physically separate workers from hazardous substances to reduce heavy metal exposure. Installing local exhaust ventilation or LEV and dust extraction system to capture contaminated dust and fumes at the source. Administrative control. This involves implementing comprehensive standard operating procedures (SOP), providing regular worker training, conducting a job rotation to reduce the duration of individual exposure. Routine exposure monitoring ensures that heavy metal levels remain within safe limits, while strict hygiene rules such as prohibiting eating or drinking in processing areas and enforcing proper hand washing prevent accidental ingestion of toxic substances. Personal protective equipment (PPE) serves as the last line of defense when hazards cannot be fully eliminated or controlled. Workers should be equipped with appropriate respirators to prevent inhalation of toxic dust and fumes, chemical-resistant gloves to avoid skin contact, protective clothing to shield the body from contamination, and safety footwear to prevent injuries from sharp or heavy components. Hence, effective prevention and control of heavy metal exposure in e-waste recycling requires an integrated approach, combining engineering solution, proper workplace management, consistent use of PPE, and continuous health surveillance. This comprehensive strategy is essential to protect workers' health and ensure a safer and more sustainable working environment.